we can pretend like we know what we're doing. Welcome everybody. Welcome everybody to P&K Space Imaging. We're live with Marc D'Antonio, looking at the moon on what's going to be a fantastically clear night in Miami, and Paul on the rooftop down there. Hopefully everybody can hear us. Let's hope.
We'll find out.
Yeah, everybody in the chat, you just want to tell us if we're both coming through for you, or just let me know if there's no music at all, which they probably will. Or probably that's where the sound goes.
Yeah, that's right.
Because we're professional here. That's all you need to know.
Yeah, Ted liked their shot of Jupiter yesterday.
I know, and you know what? As soon as I seen that alignment, I ran outside with the camera and actually took a couple snapshots, and just to make sure I had them, because it's very rare I see them like total like straight line like that. I was like, oh wow.
Yeah, it just happened to be the way the geometry of the orbits lined up. They were crossing that nodal point,
yep,
the midpoint of their orbital plane, and so it really looked nice. Yeah,
that was gorgeous. Nice wide field too. I mean, of course, I need to get a better tripod, because I tried to take it. I still got a little bit of shift in the image, like a little bit of vibration that kind of knocked the points off. So it was like a little blurry with the moons and whatnot. It's still usable, but it still looked good. But yeah, so that was a good. Yeah, as I said, I was watching your Sky Tour thing after we wrapped up here, and very, very interesting stuff. I seen you were touring the moon, so I was like, ooh, let's do this. Because very rarely do I get to sit back and actually kick back and start naming craters and all that stuff. So
I mean, it's really cool. You know, it tests your memory as well as increases your capability. You know.
Sure. And there's a couple things that can help people out. Guys that are listening in the chat, if you I can post a moon map that helps you with more of a visual aspect of it, but there is a couple apps that you can get, and one is called Moon Atlas that would really help you out with actually the names of craters and different things. I know you can get it on Android. I'm pretty sure you can get it on iPhone. Marc, you being the iPhone guy, be able to tell me. I'm pretty sure you probably have it.
Moon Atlas. I actually got rid of that one at one point because I was just simply running out of space.
It's a little wonky, like to scan across. I mean, you can get it to work, but sometimes when you go zooming in, it gets a little weird. But with being able to like just shuffle across there, but it's not a bad app at all.
There's another one called Moon Map, which is another one that's pretty cheap.
Moon Map.
Yeah.
Can you believe it's the 20th of June already? Jeez Louise.
I know.
It's been a month since Pine Bush.
No way.
It was the 19th, wasn't it? Had myself, you, Jenny.
Yeah, but that was Pine Bush that never happened.
Yeah, well, that was the first Pine. Well, that's what I'm considering Pine Bush. The other Pine Bush, I was considering like a rain delay. A rain date. But the original Pine Bush, the long, expanded Pine Bush, for me anyway, that was like 2 or 3 days. Or 4 days, maybe. When the hell did I get up there? Oh, yeah, I think I came Friday? Went home Monday, possibly? I don't know.
Well, Bill was very angry that you did not come up again. I mean...
I did come up again.
Driving up all over again. Come on now.
That was a good trip. Actually, I'm getting more and more used to it. It's getting shorter and shorter every time I go now.
Yeah.
You know, it just seemed like nothing, because I left here at like 6 a.m. and got up to Pine Bush like 9:30.
Wow.
Yeah, so it was like nothing. It was just a nice trip up the Blue Route here in Philly.
That's like me driving to Cape Cod when I used to go up to Woods Hole Oceanographic Institution, because I'd go up there because I'm outer space, inner space, and the space we're all living in is like the least favorite place for me to be. I want to be in outer space, or I want to be in the deep ocean looking at the oddities down there. And Woods Hole has the beautiful Alvin, the latest and greatest, and you know, I fell in love with the Alvin when I first saw it, and then when I got a chance to go in it, I was actually just like, wow, this is crazy. It's amazing. You know, it's a beautiful vehicle. And it dove down to the Titanic, you know, and it could go even deeper. The newest one can go even deeper than that.
Right.
Yeah, and I've seen the newest one, and then the Boston Museum of Science asked me to build them a model of it, so that we could actually, so they could actually put it out on the floor. And it ended up, we made it in this big giant glass cube that was about 6 to 8 feet high and about 3 feet by 3 feet or maybe 4 feet by 4 feet. Had some really nice graphics along the window to show the depth and stuff, and it showed Alvin with its lights on because I put lights in it. The new one now, hovering over tube worms on a side of a sulfide chimney. It was really cool.
You know what? I remember a couple streams ago that when you were on, I said I had a question about Mars, but I totally couldn't remember what it was.
Yeah,
I remembered. I actually remember today.
I still can't remember.
No, okay. You were talking about, this was right after you did the KGRA radio show on Mars.
Okay.
And we were talking about terraforming Mars and how much of a thing. Like, what would you need to kickstart a natural terraform? All right. And basically, it's like water is locked up in ice, correct? So.
Yeah, I mean, on Mars, yeah, but the most important thing is to get the atmospheric pressure up high enough to support liquid water.
I know, but what would do that?
Well, that magnetic shield project that NASA has on the table that I talked about,
okay,
that would actually do it, because right now the pressure on Mars is at 6.1 millibars typically. Now that's like 0.0061 atmospheres. We're familiar with atmospheres, which is 14.7 pounds per square inch is one atmosphere. That's like the pressure at sea level.
I want to say that just because this is what I was thinking about, and I forget the exact topic you were talking about, but I'm like, would it be possible, in order to kickstart everything, for us to take, say, almost like the kid with a magnifying glass, to take these giant, directional mirrors up into, say, Mars's, and put it in a stationary orbit around Mars that actually takes the sunlight and concentrate it to a point where we know there's ice under the surface, and just leave it sit there and cook. I mean, just let it sit there and just zoom and put all these things directly towards the ice cap. Just this, it's like a magnifying glass. It's a giant space magnifying glass to concentrate the sun onto a certain points of Mars. You know what I mean? You're still with me?
Yeah, I understand.
Which would then cause it to warm, obviously, water to flow, evaporate. Would that kickstart anything in particular or no?
Well, see, Mars has this really weird mechanism that's going on, and this mechanism is the mechanism which actually regulates Mars pressure. Let me paint this scenario for you.
All right. Layman's terms. I'm a little slow, buddy.
Yeah, I know that. I mean, that's what
you know that.
First of all, the triple point of water. No, okay, I can go through that, but I'm not gonna.
Right.
First of all, look at Mars pressure is at this very, very low point. 6.1 millibars. All right, a millibar is a thousandth of a bar, and the atmospheric pressure on the Earth is about just over 1,000 millibars on average. So we actually have very high pressure compared to the 6.1 millibars on Mars. So first of all, for water to exist in a liquid form on Mars, the pressure has to be higher than 6.1 millibars. So let's do that.
Oh, so you're talking about basically, now let me see if I'm understanding this, because water has this very rare point where it can be any of the three, correct?
That's right.
It can be a gas, a liquid, or a
right. Let me explain that.
Okay.
Let me explain how that works, because in places where the pressure is very low, water can boil. In a vacuum, if you put a water drop in a vacuum, water will just instantly boil away. Now, that's because boiling is something that is sending water to water vapor, which is boiling. Boiling is something that actually depends on the pressure. So if you reduce the pressure to 0, it'll boil. This is why you can take an ordinary room temperature glass of water, put it in a vacuum chamber, and evacuate the air, and then water will start bubbling and boiling in that chamber. That's happening because of the fact that the pressure is low. Now, on Mars, the boiling point of water is obviously going to be taking place at a much lower temperature because the pressure is much lower. So whereas on Earth, if we evacuate the air entirely, we get boiling very, very at low pressure, but you can put your hand in that cup and it'll be just room temperature water bubbling around your hand. Of course, you have to figure out a way to get your hand in there without it pooling all the blood in your hands as the pressure is so low. But that said, that boiling process is how water goes from liquid to water vapor. And at sea level, we have to heat the water, and then we call it boiling water, and it's hot. And that pressure of 1 atmosphere at sea level requires a temperature of 212 degrees Fahrenheit to boil the water. So boiling water at room temperature, or sorry, at sea level is a scalding process, something that can hurt our skin and kill us, right? But at lower pressures, water will boil at a lower pressure. On a mountaintop, water will boil at less than 212 degrees Fahrenheit. Okay, so that said, on Mars the pressure is 6.1 millibars, as opposed to 1,000 some odd millibars. So water will almost immediately, as soon as the liquid water rushes out, it'll almost immediately begin to boil away.
Okay.
All right. So now we have to raise that temperature, or sorry, that pressure higher than that 6.1 millibars, because that is the point at which the water can stay in liquid form on the surface.
Well, what I'm saying is, what would raise that pressure?
I know. Let me explain.
All right.
Let's suppose that we ended up with an extra amount of water vapor in the atmosphere. Let's suppose that something happened, such as you're talking about. The ice caps melted. Pressure increases. Liquid water is now able to form on the surface of Mars. Okay. Now, Mars has this weird problem. As soon as that happens, the water on Mars, hungry for carbon dioxide, okay, it's a carbon dioxide will go into water very easily, and water is a well-known carbon sink. All right, it'll suck it up like a heat sink. Okay, it sucks up the heat from something. Right. Water will suck up the carbon dioxide from the atmosphere. So, liquid water now forms on the surface of Mars. The CO2 atmosphere, which has been getting thicker through processes where we actually either artificially created it or used our magnifying glass to create water vapor in the atmosphere to make it thicker, that water vapor and the carbon dioxide that is generated normally on Mars will actually then start sinking into the ocean. It'll be absorbed by the ocean and get processed out. Now, the more water surface on Mars, the more that process occurs. Thus, the atmosphere keeps getting thinned by the very thing that we want to, by the very thing we need, and that is the water. So when that happens, it'll get down to that 6.1 millibars again, and the water in the standing water on Mars will start to boil away again. So in this way, Mars regulates its own pressure, and we have to get past that. And the reason that we have to get past that is because when you have a situation on Mars where we don't have a magnetic field, then the sunlight, as soon as water evaporates off the surface for whatever reason, out of standing water, as soon as the water evaporates, the sunlight will begin to attack these molecules of H2O in the atmosphere. And because there's no magnetic field to protect the atmosphere, the high energy particles, from the sun will take those H2O molecules and split them apart, leaving only hydrogen, which gets lost to space, and oxygen, which sits there in the atmosphere but eventually makes its way back down to the ground because Mars gravity can hold down oxygen atoms. And when it does, it binds with stuff in the Martian soils. That's why Mars is red, because oxygen in previous iterations has bound with the iron compounds, making Fe, iron, Fe, and then O2. So Fe,
oxidation.
Iron oxide.
Right.
So in this way, Mars constantly has this problem where without this magnetic protection, any CO2 and H2O that goes into the atmosphere gets absorbed and processed out of the atmosphere, causing the very problem all over again of low pressure.
And I will say this for anybody that wants to hear more about this. I know that you did go into some detail on there being a couple theories in a way they can produce an artificial magnetic field on the show that you did for KGRA. So if you guys want to check that out, just jump on the KGRA and look at the go back, what is it, 2 shows now?
Yeah, they can go to our Sky Tour radio archives on KGRA and look for the Mars show.
Right, and you can hear all about it there. But yeah, that was the thought I had. I'm like, what if we just kind of concentrated light and started melting? What would happen? But hey, you pretty much answered my question. And we should say what's up to everybody in the chat. Let's go down this participant list, because I do see there is a bunch here tonight. And my cat is attacking my hand. All right, we got Tana and Chris and David and Dee and Jenny and Mark and Rockstar and Stanley and Ted and Volt. And we did it. I think we did it. Yeah. Oh my God, Cat. Jeez Louise. What a little bastard. So what's going on, everybody watching on YouTube and participating in the chat? If you guys have any questions for Mark, you can go ahead and ask away. We both are watching the chat. I believe you are. Correct, Mark?
What's a chat?
Exactly.
Hey, this Sunday on SkyTer Radio, we had to abort this last time because of the curiosity findings. So we did another show on Mars and the methane and the organic compounds that were found. And what I wanted to mention is that we were going to do a show on Jupiter, and we're going to go through all the atmosphere on Jupiter and talk about how Jupiter formed and why it looks like it does, why it's not a star, what would be needed to make it a star, and how that process works if it were to be. So that'll be Sunday night at 9 p.m. Eastern. So if you want to do that, tune in. It'll be our Jupiter show, and this is in the ongoing shows on the history of everything. And we did the Earth, we've done Mars, now we're going to do Jupiter. Then we're going to, in terms of the history of everything, we're probably going to talk about stellar nebulae, that is to say, nebulae out of which exoplanets and other planets formed around stars. So
nice.
That'll be also probably in the weeks following, we'll do that. So we have this history of everything thing. And we'll also talk about the moon. That moon is a special case, so we're going to actually talk about the moon as well. And that'll be for another broadcast. Not sure when we'll do that, but there's a lot I want to talk about with the moon.
So with Earth's moon.
Yes.
Okay.
And I may have you on that show. You may be joining me for that show.
Okay.
Yeah, because I think that you might be able to raise some interesting points.
I'll try my best.
Yeah.
Now
we have 3 days, don't we?
Yeah. And I'm just gonna kind of let it go by the wayside and let it do its now. Hopefully, we'll have a good night Saturday night. I mean, the weather we've gotten away with now 3 days in a row, 4 days in a row, 3 days in a row. That the wind has been coming out of the northeast, and it's just been perfect down there. You get a little daytime clouds, and then they disappear very quickly once the sun goes down, and it's been really nice. As you can see, the air is starting to calm down a little bit from the heat. Yeah, it's very, very nice looking. Speaking of KGRA, I was listening to it today. I was driving around getting some stuff done.
Yep.
And I was surprised to hear a couple of skeptics on there this afternoon, and I heard Ronald. ERRT radio. I'm not sure if he's here or not, but I heard him call in, and he actually was giving you and Eric props because the guy was talking about people that do the conference scene, more or less, they make it a career instead of doing it, for basically to find out truths. Like it's. I know they were very critical of Richard Hoagland and people like that, but you are one name that came up as one of the good ones.
Oh, well, whose show is this?
I couldn't tell you because it doesn't say on the app. It just comes up unknown rebroadcast. So yeah, I wish it did. I would have told you, But I bet you can ask Bill because it came on right before today. It came on right before.
That'd be the 19th.
No, today, 20th. It came on right before, it wasn't a live show, it was a rebroadcast, but it came on, what's the guy's name? Richard Dolan. It came on right before that, so it was like right before 3 o'clock at some point today. And hello to Heidi. I see she just joined.
Hey there, Heidi. How you doing?
But yeah, I was surprised to hear some skeptics, and this guy was kind of going in on, because it was a guy from Canada, a researcher from Canada, and they were talking about, UFO abductees, and...
Not Robert Stanley, is it?
I'm not sure, to tell you the truth. I wish I knew the name. I'm spraying my cat with water so it gets out of my way. But it's not working. He keeps on just... wants to lay on the wires, and he wants to lay on the switch that controls the whole computer system.
It's
So
better
I'm
than
afraid he's
spraying
going to
the
hit that thing.
side.
I gave him one of the computer mouses because he was getting mad that I was clicking mine. So I gave him one of my old ones, and he's over there pressing it and clicking it. Oh, Jesus.
Heidi says Grant Cameron. Was it Grant Cameron?
I think Grant Cameron was part of it. Was part of that show. It was like 3 people. Yeah. But I found it interesting. Like, he was basically going in on some of the people that, you know, and then there was an older gentleman that called in and kind of went in on Travis Walton, saying how Travis Walton changed his story. And then he went in on the guys from Rendlesham, saying that they changed their story. Now, as far as I know, once again, I'm not really up on the whole UFO thing, but as far as I know from Travis Walton, I don't think his story has changed. It's become more elaborated, you know what I mean? But I don't think it's actually changed at all.
Yeah, I know Travis fairly well.
And well, here's the thing. I think, and it comes to a point.
Story in decades, the story's been the same. It's just that when he retells it, sometimes he just tells it from a different point of time.
Well, that's what I'm saying. I'm thinking maybe like as you get older, like obviously he's not. You might remember stuff as you get, you know, as time passes. You might then try to start interpreting what, you know, maybe these beings were trying to tell you, you know, or, you know, over time, because obviously you wouldn't be able to process it right after it happened. I mean, that's a pretty, you know, devastating thing to happen to you. So I'm thinking, like, but once again, I don't think his story itself has ever changed. You know?
No, it hasn't. It stayed the same. I'm a big supporter of Travis because of the fact that he's one guy whose story has not changed.
Right.
He embellished it over the years. He's not a Corey Good who talks about going to Mars, you know, and then you hear these guys who say, "Well, I went to Mars with Obama." Oh, okay.
Yeah.
In 5 years it'll be, and then Trump joined us, and then right behind him was Oprah Winfrey. You know, I mean, before you know it, you're gonna have all these people that have gone to Mars, and these people that aren't really anybody are going to then, you know, claim they are somebody because they were with somebody important when they went to Mars.
Right.
I'm sorry.
I'm not sure how to take some of that. Like, they're hard to believe. Like, they're really out there. But you wonder, like, who was the guy that said he went with Obama? Was it Andrew Basiago?
Was it Basiago?
I think it was. It was the lawyer guy from the Northwest. Yeah, it was Basiago. Said something about jump rooms in San Francisco or something like that. I remember hearing about that a while ago. But when you see interviews with this guy, he is totally 100%. And once again, that's another guy that his story has never changed.
Well,
you know?
I mean, it's the thing. I mean, now, I think that people sometimes when they tell a story, after a period of time, it becomes the truth for them, even if it's not. And you really got to be careful about that. You know, and then when that gets mixed up, then, you know, they'll even pass polygraphs.
Right.
You know, because they actually believe it. They believe their own hype.
I mean, and I kind of sided with the guy when he was talking because he said, you know, some of the conferences that go on across the United States and wherever else have become, you know, what can I sell you? You know, and obviously these people that, you know, do travel around and people want them for these talks have to, you know, have some way to pay for this stuff. You know, to be able to travel. Sometimes I'm guessing you would know more about this than I would. That, you know, I'm not sure if these people, like, they get paid for their speaking engagement. I'm pretty sure that they do. You know, especially if they're going far away. But
I mean, there's an honorarium system set up.
Right.
You know, even I get paid, but, you know, I get paid an amount of money that usually doesn't quite cover, you know, checking bags when you fly. I mean, it just barely covers that stuff.
Right.
And that's all it's for. You know, you're not going in to get paid $15,000 or $4,000 or $2,000 to do a talk. There are people that do.
Well, this guy was basically saying, be wary of anybody telling you something that's happened that wants to sell you something. And
I mean, that's rule of thumb for anything, isn't it?
Very true, but I was trying to, like, negotiate in my head. I'm like, is that fair? You know what I mean? Like, say if something happens to fly across the screen right now, and we know it, and we do all the scientific tests, and we confirm it's definitely something that's not ours. Okay? do everything in our power to do that. Okay, and then somebody invites us for a speaking engagement, but they're paying us, $500 to go talk about it out in New Mexico somewhere. Well, that's not really going to cover a lot. So do you like? I mean, I'm trying to think. Would you sell like the clips of the UFO to try to make up a little bit more money, make it worth the trip going out there, or do you just do it for the sake of doing it and telling the story of what happened?
I think it's important to tell the story, but what I don't think is important. And it's important also if people want to see that and hear that, then you have every right to ask to be paid for that. Because there comes a point where the truth does matter, but you also have to live, and you can't be a pauper going to these things, because then you're not keeping up yourself. You're not being true to yourself.
Right.
I mean, there are honest people who believe wholeheartedly in the things that they've experienced and do wish to get paid for what they do.
Right.
That's not actually a bad thing.
I think that's where Travis gets a bad whack.
There's a fine line.
Because he is such in demand, because it's one of the most studied and it's one of those big cases on Earth, and he's in such high demand to do talking and stuff like that. And of course he's going to have stuff to sell, because he still has to live. He still has to have a home to go home to. And I think he gets a bad rep, like no matter where he goes, he's always selling something. Well, of course he is. He still has, he still have rent or a mortgage to pay.
Yeah.
So it's like, and I think it's an unfair bad rap that they get, because they had this happen to them, but of course they're doing a little extra to get the money so they can do, what they're trying to do, what people want them to do, which in Travis's case is speaking engagements.
Yeah, that's true.
It just got me thinking about that today, and it was weird, and I didn't expect to hear it on KGRA of all places, but it was there, and I applaud them for actually having the other side of the coin on. Once again, I wish I knew whose show it was, but I don't. So, Race, if you're listening, fix your app, man, or Bill. I already told Bill about it, so maybe somebody will fix it. But has anybody else used the KGRA mobile app for Android or for iPhone? Does your text thing work when it's broadcasting and tell you actually who's on? Because the only thing that comes up on mine is unknown, and then it has rebroadcast. So I think it's called, what do they call, the IDN tags or ISDN tags or something like that on an audio file.
Yeah, look,
has to be they have to be actually inserted into the audio file for it to come up on the app. So yeah, anybody that uses the KGRA app, let me know. Maybe it's just mine, but it does. But I did check it on the computer, and it doesn't work on the computer either.
So is this when you say listen live?
Yeah. You click listen live.
Yep.
In the top right corner there, and it'll come up. And then, now he might be doing a live show right now, so it would come up then. But if it's a replay, it just comes up unknown and then rebroadcast or whatever. So, yeah, anybody in the chat that's a KGRA listener, let me know if you listen to it on iPhone or Android. But yeah, I haven't had a problem with the actually KGRA site. Tana says I tried using the KGRA app on my laptop and had no luck with it. Just try using the actual website, Tana, instead of the app. Just go to actual KGRA.com, listen live, and then Weird Guy says, yeah, gave up on the app except for the audio feed. Yeah, that's all it is on the app is the audio feed as far as I know. They have a couple little things on screen, but yeah, it's just the audio as far as I know.
Well, I don't know who's on right now, but when I look at the
let me look what it says. I'll try it here.
Listen live, I get SkyTour Radio presents The Universe Was Calling Them, which is our Sunday show.
Mm-hmm.
I don't know if that's a targeted ad for me because it was my show.
Well, hold on. I'm putting it on right now. I'm going to tell you exactly what mine shows.
All right.
Okay, listen live. Clicked it. Takes a
Tom
little...
Brown, KGRA is the online radio station, KGRA Radio on KGRAradio.com. It's a radio station based out of Ogden, Utah. We have nearly going up to about 1 million listeners. and it's one of the bigger internet radio sensations out there, actually.
Oh, okay. Now I know what we have to do. Okay, Listen Live is on.
And Heidi put in the link so you can see it's kgraradio.com.
Okay, okay. Listen Live is on. Okay, it doesn't tell me what it is, but if you close your phone out, and you have how you have your, not your home screen, but when your phone's like, when you're not inside your phone, it has the locked out screen or whatever, but it tells you what's going on in the background. So I did that. I shut my phone off just so I have the outer screen with the time and everything, and it says KGRA and it says -unknown.
Okay, see, mine just says KGRA. It doesn't even say unknown.
Okay. So yeah, it is on. It is on KGRA's, and then, yep.
Yeah, I'm listening to it here.
Yeah, I got it. We got to say, don't get me wrong, it's a great app. Once it's on, it works great. It just doesn't tell me who I'm listening to, which is kind of annoying.
That's kind of an oversight, actually.
But I mean, you can definitely tell when you're listening to Richard Dolan. You can definitely tell when you're listening to the lady. What's her name? Because they're on there a lot, and they have a lot of replays of Dolan and what's the lady's name?
Linda Moulton Howe.
Linda Moulton Howe. Yeah, you definitely know those two shows, and you know now I'm forgetting everybody's name.
Oh, you got Patrice Sheridan.
No, there's 3 shows that are really popular, which is Dolan, her, and then there's another guy that's been doing it for years.
Oh, that would be Jimmy Church.
Yeah, Jimmy Church, but there's another one too. But anyway,
that would be Don Ecker.
Don Ecker, that's the one. So yeah,
Don and I are good friends. We actually known him from, oh gosh, many years ago.
Sweet.
I used to be a private investigator and a cop. The guy is just incredible.
Yeah, and as I said, don't get me wrong. Once it's on, I mean, it holds signal pretty. I mean, once again, I'm out here in the boonies. So, why is Jenny saying hello to me? Or is she talking to another Keith?
There might be another Keith.
Let's see. Ingus already? No. Maybe she was talking to me. Did we lose audio for some reason? I don't think so. It looks like it's still on. Jenny's confusing me. But yeah, once again, KGRA really good if you're in that kind of stuff. Once again, I'm not the biggest in the UFO stuff, but I have started listening to it ever since getting hooked up with Bill and whatnot, and I've been trying to understand it more because I don't like talking about a thing unless I kind of at least understand it somewhat. So I've been trying to listen a lot more and find it really fascinating. But yeah, they really need to fix who I'm listening to so I can so I can tell you. But yeah, Richard Dolan gets played a lot.
Yep.
On there in replays, and Linda Moulton Howe as well.
Jenny again.
Yeah. So how's the moon looking, everybody? It is really calming.
Having some serious moonquakes. I saw it shake a whole lot.
Yeah. But man, oh man, I tell you, I don't know what Paul's doing down there, but he's. It seems like he's almost writing down conditions to know what's best, because it's been weird lately. The moon at zenith has been horrible, but yet it comes down to around, anywhere from 40 to right around now the 55, 56, degrees, and it's like perfect. I'm not sure. Maybe that has something to do with the atmosphere above them, or something weird going on.
This view is beautiful.
Yeah, especially that man. I should actually get out the app and start naming some craters for people.
Well, unless Paul's on it with us, he's gonna kind of just zip on by as we're trying to work something out,
Hey, yes, but once again, we can use the Terminator as a reference point and and we know which way the moon's lit from. And if you guys look on screen, and I'll actually make it flash here in a second, you will see what the correct orientation is of the moon. That's actually its correct orientation. So if you look at the picture that you're looking at, and obviously we always try to keep the lit side on top, you would just kind of turn it 90 degrees, and that's would be the normal moon you would be looking at. I'm not sure why he does that, but it seems like so we can get the most of the lit part in frame,
Yeah.
And it works out pretty good. And once again, it's not really a pain in the butt until you go full moon, which normally most times Paul will leave it, orientated correct when it's the full moon, because there's no point in shimmying it around at all. But man, oh man, it's getting to look nice, and the air is calming down nicely, and I'm pretty sure we're going to go crater spelunking very shortly.
I know Chris asked us, but I know that it's going to be give me a little bit of time, because when we start naming craters, we actually have to have a pretty
look at this. Oh wow. We are going in. Just I mean, just to see the inside crater wall definition is just, and then some of the aprons.
Yeah.
You know, the crater aprons around the outside, just amazing. And this is, I mean, these kind of nights like this is why we do this. You know?
It's beautiful.
And the people look at it like, oh, what's that thing in the middle? It must be a building or a house. It's like, man, that building has to be 1 to 2 miles wide. Not to mention it was a mile high.
Well, that building's actually a central peak.
Yeah. What we call complex craters.
Right. You got it.
And actually, next time I'm up that way, I do want to film. We had talked about filming, dropping a marble or something in some thing, and actually making our own craters to show people how they form.
Yeah, I got this lunar soil that I made, and it does everything that lunar soil does, except give you silicosis.
Well, do you think there's a way we could use some sort of, I want to say hit it with a rock, but I wonder if there's something that we can use to make it disperse once it hits. You know what I mean? Like some form of liquid that maybe drop it like just at 32 degrees, and by the time it actually hits the moon dust, it would be almost water, like that kind of. I don't know how we would do that, just so it would get liquefied on contact. You know what I mean? Like a normal asteroid would among impact with the kinetic energy and all that stuff. You know, coming in at super fast speeds.
Yeah, I think that it might be. I think it might be a really good idea to look at that.
What if I have an idea, and tell me if this will work?
Okay.
What if we take a box, we make a box, and we cool it with dry ice and make it really cold inside this box? Okay? And then say we find, I want to say Jello, but something like Jello-like, you know? And actually be able to drop it down through there so it actually hits the surface, and maybe if it does turn into a liquid, refreeze then, like right away, because it'll be so cold in the box, you know what I mean? I think you could do it with dry ice, because dry ice is what, like negative 180 or 200 and some degrees?
It's like about minus 90 or so.
Really? Is that warm?
Yeah. Well,
oh yeah, well, it is carbon.
Hardly warm.
Yeah, it is cold. It will burn you.
Well, yes, it does the same thing to your skin that fire does, because it affects the nerves the same way.
I'm all about experiments.
The actual temperature of dry ice is around, it's like negative 100 or so, negative 10 something, 109, I think.
Right.
But it's really, you know, it's a very, very interesting substance, because things that happen with dry ice that you can try, which are really cool, besides throwing it in water and then swimming in like a boiling water. Oh wow, look at me.
Right.
Is if you take a hammer and you hold it down to the dry ice and just press it onto a dry ice block.
Oh, believe me, I know.
It'll start screaming, you know.
Yeah.
And make these really cool sounds, and it's because of the pressure and the sublimation, that is the instant passage to gas of the ice. Okay, that goes from that ice to gas. That's called sublimation. I used
to work at an ice company back in my teenage years, and we would sell ice blocks. They came in 50-pound blocks.
Yeah.
From a place, a lot of people might have seen their trucks driving around. This place is called Air Liquide. They're a big supplier of dry ice. And we had this chisel. It was a pretty thick chisel that we would use to cut it up into smaller blocks that people wanted to buy. And if you would just hold that chisel on the top, and that thing would start screaming in a matter of like 10 seconds. I mean, it'd be whizzing. You know, and usually scared the heck out of people. We had to make sure to tell people, you know, don't touch it with your bare hands. You know, even in a glove, I mean, you want to get it in and out of your hand pretty quick.
See, at the studio, up at Doug Trumbull's studio, we had liquid argon and liquid nitrogen that we play with, because argon and nitrogen are very interesting substances, because when you pour them out of like a shower head, as it falls, you see liquid drops, and it looks like water. But if it splashes on anything, including like the back of your hand, you don't catch it in your hand to cup it, okay? Off the back of your hand, you get these little explosions of instant sublimation to gas from the liquid. And it just is crazy watching that happen. And, of course, it's very cold. And we would take the the liquid nitrogen, and we use it. We'd make what are called nitrogen curtains. We would actually put a camera down low on the ground and then drop liquid nitrogen toward the camera from some height, and we would light it very dramatically. And what you see when you play it back, especially if you do this in slow motion, like 1,000 frames a second or whatever, you would actually see these little tiny particles of liquid nitrogen, individual drops, falling like little comets. And as they fell, they would be trailing this beautiful cloud of gaseous nitrogen behind them. And we use that in a lot of our commercials and stuff we did up there, really, and in our movie too. I mean, it's really amazing how liquid nitrogen is such a different substance. It's very different from what people ordinarily see. So when you see it in action like this, it's really amazing to watch.
Not only that, but you can carbonate any drink you want.
Well, not with liquid nitrogen, but
no, with the dry ice.
Yeah, I mean, you'd have to sink it into solution. It doesn't really carbonate the water. That's not how the carbonation seems to work.
It did for me.
Well, it might, but I haven't. I haven't played with carbon.
Just take a little nugget size and throw it in water, and let it totally dissipate.
Yeah.
Not with a cap on, or you have a mini bomb.
Well, we made several of those actually with the dry ice.
Once again, I should say this, and I shouldn't have to say this, but this was in the news. If you do have dry ice, do not, and I repeat, do not try to use it as an air conditioner, or like put it in the back of a fan with like closed windows, because you will die. Okay?
CO2 asphyxiation.
I couldn't believe there's this guy, I think it was called Crazy Russian Hacker. And he was like, oh, you can make your own homemade air conditioner. And didn't say anything about people suffocating if they're in a really enclosed area. But he was doing it with dry ice, and I'm like, dude, you might want to tell somebody about that, That's one of the big side effects. But, yeah, so do not try to use it for any of that. If you want to keep stuff cold, even big, huge freezers, we've had companies, with big, huge storage freezers for, like, motels and stuff and hotels. All you got to do is throw 4 50-pound blocks in there and put them on the top shelves, and they'll keep everything frozen like nothing. But when you open the door, you want to let it air out for a minute before you go inside, because you will faint. Yep. Yeah,
that's true. And I've seen people throw dry ice by massive amounts into a pool and then jump in.
Mm-hmm.
Well, what do you think you're breathing when you look at that white cloud? You're breathing carbon dioxide. And you won't survive for long in that heavy mist. So you got to be really careful.
Sorry, I'm just kind of tweaking, and we have the spot tonight, and we'll see it move off to the right. I'm tweaking Jupiter a little bit.
That's really, really pretty, yeah.
And then he's going to overexpose it for a second. He does this a little bit in and out just to get it just right on his end, and then I take it over from there. So once I usually wait until he gets his set, and which is nowhere near the color coming to me, but it's set on his end. And actually, I can actually show you when it comes up what it looks like when it's sent to me. I'll turn off all this stuff here, and you'll see it's almost purple. And then I correct it from there. Yeah, I'll show you here.
Oh, actually, you might be using a
here you go,
a sky glow filter.
Let me, we don't use filters. Here you go. So this is, you're looking at it now.
Yeah.
Which is me. Okay, and then let me turn it off. It actually looks pretty orange tonight, so let me turn it off real quick. And that's what it looks like when he sends it. Now, once again, it only comes through like that. On his screen, his is perfect, but for some reason it comes through really awkwardly, but it kind of looks like an orange. So then we take that off. And then we get it a little more clear. Optics for the win.
Ted's asking me a question about the band. Well, Ted, the answer to that question really has to do with Jupiter's atmosphere. It's actually, that large band is actually very detailed, and we can't see all the details, but there's a lot of convolutions and squiggles and swirls in that big thick band. So and believe me, I've made many 4-foot diameter Jupiters for projects we've done all over the country, and that 4-foot Jupiter is always changed because of the nature of the bands and zones on Jupiter that have changed. It's really pretty. I'm just totally enamored by Jupiter. I can't tell you. You know, it's just beautiful.
Yeah, and he's going even further. Okay, let's just tweak a little bit just so we don't get some puffiness. Oh man, look at that. If you didn't know any better, you'd almost think that was a stacked image.
Well, can you imagine if you took 45 seconds of video and then stacked the images?
He does.
Well, I'd like to see the finished product because it would really be pretty. I can see how this would be a beautiful image.
So, Paul, if you're listening, Mark would like to see a stacked image of Jupiter.
Yes, I would.
He might be listening because I did tell him you were coming on, and we might actually have Bill join us later too. If he gets on the live stuff, he's doing a live record or something.
Now let me just clarify something for folks, because when we talk about bands on Jupiter, we're actually talking about bands that are dark. So those dark bands we call the belts of Jupiter. They're the cloud belts, and the light ones that you look at, the white ones, are called zones. All right, so it's belts and it's zones, and so we're looking at that brown thing that you're talking about. All right, when you're talking about that, you're actually talking about the north. I think it's that north temperate belt that we're talking about, which is that large belt that's seemingly broken up a lot, and it's broken up a lot because it has a lot of detail in it, which is changing from time to time, just like the spot has changed in size from time to time.
Yeah.
Farther up above that north temperate belt, we have something that's actually that next white zone above that north temperate belt is called the north temperate zone. Yes, two norths. North temperate zone, NNTZ. And then there's the north temperate belt above that, right? Then we have the equatorial zone, which is kind of above the spot, and then where the spot is, that's called the south tropical zone, actually, where the spot is, in that kind of whitish area.
And the other night, I was actually telling people about our record, and what the record I was talking about is 14, basically 14 bands, which is the separation between zones. There was 14 individual zone separations between light, dark, light, dark. That's our record. And the other night we had 11. So 14 is our record, zone split. So just for anybody that didn't understand that, and I should actually take this time to give a shout out to our brother in arms. Over in Germany, there's a channel called JW Astronomy here on YouTube.
All right.
He doesn't stream very often, but when he does, it's great stuff. Really good stuff. So if you get a chance, check out JW Astronomy here on YouTube. He actually did a couple months back. He actually did a transit, ISS transit of the sun, which was awesome. Yep, and then he was streaming a little bit earlier. It was around 5 o'clock this time, and it was a little late for him. But I was hanging out over there for a little bit and checking it out. He was doing Saturn and Jupiter and the Moon as well. Really good stuff.
All right, that's neat.
Yep, so JW Astronomy on YouTube. And he does have a website and he does have a Facebook, so you can find him on any one of them as well. Really cool guy. Does speak English and German, so you can, if anybody's here listening from Germany that wants to hear some German, you can speak over there. And he does come on cam. He does have a webcam there, so you can see him. And he does leave all the frame references up on his software, so you can see what he's doing. In the actual software part of it.
Yeah.
So I thought that was pretty neat as well. But yeah, check it out. You too, Mark. Check him out. Really good channel. He's actually a bigger channel than we are.
Wow.
Yeah, I think he's up around 56,000 So
Cool. Really cool.
yeah, so he's really making waves over there in Germany, which is awesome. So check him out. So what about, are you going to sign up to join the Space Force or what?
Oh, I'm already in the Space Force. I'm Lieutenant Kiss My. Oh, I'm sorry.
So what's your thoughts on it?
Well,
Good
I mean,
idea,
the
bad
Space
idea,
Force,
bad timing, good timing?
well, the Space Force is not a, it sounds like a real big thing, but you know what? We've already had a, believe it or not, we actually do have something called a Space Command. And it's not what everyone thinks, the secret space program or anything like that. It's actually an organization to actually track and make sure that any rocket launches or satellites are in safe orbits because we have so much junk up there.
Yeah.
And Space Command is going to be in part making sure that some of the satellites that are deorbiting and coming back down to the Earth don't strike in populated areas. There are ways to forestall those events, so they have to be on top of all the decaying orbits for some of the older junk up there, kind of a thing. So that's important too. And that's really important to track that stuff. I really think so, and I'm all for it. And by the way, just before Paul gets off this, what I would like to do is I just want to make sure and give people an idea in those dark belts and those light zones. Okay, in the dark belts, material is actually sinking down into the atmosphere of Jupiter. And those white zones, materials coming up. All right, it's sort of warm material as opposed to these cooler material that's sinking down in the zones. Then in between the bands, in between the belts and the zones, at the border between those darker and lighter areas, there are winds that move equatorially, circularly, and they assist in helping create these zones and belts. So, whereas one set of winds goes, counterclockwise below the belt, when they hit below the belt, hitting below the belt, they actually go clockwise. So they swap directions, which is really interesting, and that's why we see Jupiter segregated into these bands as it is. Now we're just seeing the finished product here, but Jupiter formed. There was a tremendous amount of turbulence in the atmosphere of Jupiter, and it didn't look like this originally. There's a lot of impurities in Jupiter's atmosphere, and these impurities will actually, create different colors that we see.
Jupiter's also a radiation monster, isn't it? Like a lot of radiation emanating from.
What'd you say? Jupiter's what?
A radiation monster.
Oh yeah, and that's true, and that's probably because of the liquid metallic hydrogen in the core. Jupiter has a heck of a magnetic field because of the. In fact, you know what? The solar radiation heading to Jupiter isn't even allowed. It doesn't even get to Jupiter.
Look at that! Oh my, we're close.
Yeah, I see that.
Keeps on creeping in. Let's see if I can just do a little tingy adjustment here. I don't want to go because if I pop the contrast, the whites are going to drown out some stuff. So actually, I'm going to go a little bit dimmer. And once again, this is right around zenith, and it's probably not the best look we're going to get tonight. We're going to get the better look when it crosses zenith in the,
yeah,
in the setting range.
I know it.
Wow, Paul, my man.
Absolutely.
Getting her done.
You're done.
Getting her did. Wow. Yeah, 4K 60. Tell me, imagine if it was actually sent to me in 1080. That'd be the first step. Don't worry, we're working on it. We are working on it. We're trying.
I suppose you would be, huh?
Yeah. That was Florida, by the way.
What'd you say?
I said, how was Florida?
Oh, okay. Sorry, I actually I got back yesterday, and it was really good. Then no, actually, I got back Monday. Sorry, today is Wednesday, right? Because I had a day to get ready for filming today for season 5 of What on Earth, and they were here since 8 o'clock this morning. They just left a short time ago, and that's why I kind of had to, first of all. Getting on with you, I had to do a few more things.
Not a problem.
Yeah, that's all right. And they're heading down to Washington, D.C. tomorrow, start filming the rest of the folks they have to do for this particular season.
Yeah, are you the only one they actually come to?
No, I think they drive all over the country and fly all the different places. They try to do that for all the people that they want to have as contributors. I'm certainly not the only one, but I am the only one that's doing image analysis for them. So since mostly we see images, I tend to get a good number of stories.
Sneak peek, anything cool? Anything baffling you see today?
Well, I'll just say this. The Chinese are at it again.
Oh, boy.
Yep. Chinese are at it again.
The Chinese are at it again.
Last season I found out I was able to show that the Chinese were building up a missile defense on an island in the South China Sea that they don't really have the rights to. Interestingly, as that story broke, they rushed all these missile launchers off the island. So I don't know, is that a coincidence? Maybe. I'd like to think it wasn't. I'd like to think that we exposed it, but there's other analysts out there, and I'm not naive.
When is this season due to air?
I wish I knew. I don't know when the season's going to air. I'm
pretty sure that they would have it on the website somewhere. If you go, this is for What on Earth, right?
Yes, it is.
Okay, so if you go to Google What on Earth, what is it? Discovery Channel that has that,
or I think it's Science Channel?
The Science Channel.
Yeah, Discovery's NASA's Unexplained Files.
Yeah, if you do that, you can probably figure out when the new season. I'm guessing they're filming the next season right now, so my guess would probably be fall sometime if I had to take a guess, because usually they film, and that's usually when the new episodes come out, is in the fall. So my guess would be September, October, right around there.
Yeah, it might be.
Might be sooner. I don't know.
Well, see, one of the things is if they finish a story, then they might air that story. As long as they got every piece of that story, but they might not be done with the other stories. I remember last season it was like that. There were several there were several stories. I just read something funny. Sorry. There were several stories that actually didn't get. Let's see, what's the word? They aired several stories.
Didn't make air.
Well, they did. There were several stories that actually were aired before they actually finished filming that season. So they were editing on the fly, or not on the fly, but they were editing thoughtfully, but they were editing and getting programs out while some of the data and content for the next programs down the line were still being assembled. So it's a pretty
it must be a pretty popular show if they're wanting to get it out as quick as possible.
It is.
It must be a nice ratings one for them.
It is. It's actually doing very well, and I'm very surprised that it's doing so well. And not because I didn't have any faith in it, but because typically these shows have a certain formula that kind of gets old.
Right.
For 5 seasons, this has not been getting old. So
who's the producer of that show? Because they just send just a camera crew, right? And they have the camera crew and maybe somebody.
I get a producer and a camera and sound guy.
So you get probably an associate producer or something that comes down.
Yeah, and they basically come out and they do their thing and they ask all the questions.
Let's see.
Sometimes they want me to say things their way, like instead of geyser, it's geezer. So I just say no, it's geyser. They call them geezers. So here in this country, that's an old person, an old geezer.
I still won't forgive that aliens on the moon crap.
Oh no, I can't.
How they built you up for an entire hour. It's like, when we come back, image analysis, and we have a blah blah blah, and it kept building up and building up. 45 minutes in, you're like, okay, let's just see it already.
Yeah, really.
And you come on, and you literally have a 5-minute segment, and they didn't even say, they didn't even air all the stuff that you said.
No,
it was picking and choosing, to fit an agenda, and it just kind of pissed me off.
Yeah, it's almost like you could have almost heard the edits. It's like, well, I think this is a alien thing on the moon.
See, what you have here is an alien spacecraft.
There you go.
I was like, what the heck is this? And it's like, it was basically like promos throughout the whole hour of you just like staring at a TV.
Yeah.
And I'm like, okay, it's the same clip 10 times now. And then we finally hear, from the science side of things, and it's like 4 minutes. I'm like, you gotta be kidding me, because it was the people that were talking about the satellite dish on the moon and the big arcing bridge, and these things that they very cleverly highlighted in these photos, so to make sure you saw it,
And I was able to show exclusively and explicitly with my lunar soil simulation that I did, actual real simulation along with lighting, and I used studio lights, and I actually got I made the actual visual effect of that arcing bridge to show them how it works.
Right.
But then when the producer walked into my visual effects shop, saw the whole rig and the setup, and I showed him how that works, he looked at me and said, "Oh, that won't get on the show." I said, "What? This is how, and this is what it is." He goes, "Yeah, well, that won't get on the show."
Yeah, I would almost make people sign a clause if I were you. Like, listen, if you want me on here, you at least gotta, include my side. I mean, I know it's pretty good exposure, like your name wise and whatnot, but if they're just gonna pick and choose,
Well, they sold a different bill of goods to me than they actually produced.
Well, lesson learned, right?
Yeah. Well, but see, here's the thing. Now with NASA's unexplained files and What on Earth, they don't ask me to say anything that I don't want to say. In fact, they'll say to me, explain this in the way that you want to explain it. So at this point, after this many years working with them, they just say, explain it the way you want to explain it. And that'll be fine with us. I'm sure you'll be fine.
And what I've seen of those shows, I mean, they seem to do pretty good.
Yeah, I mean, I get well, if I say it my way, then it's my words.
Right.
I'm not I don't have any words being put in my mouth. It's not a case of anything that's my words are my own, and so when I say them, they're my words, and they're not being corrupted in any way.
And we should mention to the people in the chat, pareidolia is a very real thing. Now, yes, when it comes to the moon, if you see something that looks, say, like a building or a moon base, quote unquote.
I mean, I see Mickey Mouse right now. See that?
The best thing you can do is wait a couple days and look at that exact same area, and you're going to see something totally different because the light and shadow are constantly changing.
Yeah, and when people say it's the trick of light and shadow, you know what? Before you just say it is not a trick of light and shadow, why don't you just give it a break, take a breath, and come back a day later, 2 days later.
Yeah.
And better yet, there's websites out there that actually show you every single day what the moon Terminator looks like and all the craters and what they are on that Terminator.
Mm-hmm.
And you can go dig up those sites. I think it's SVS is in the if you said lunar phases SVS,
right,
search, you'd find it. And this will show you everything that's on the moon's Terminator and the craters that are visible, and you can actually see for yourself what it looks like, because you can go through day by day and see what changes on the moon, see how it looks, because how it looks there is how it looks to you outside.
Yeah, and don't get us wrong, people. We would love to find a moon base. Just one. Well, number one, I mean, any kind of thing built there by man. If there is somehow a lunar base up there with humans working at it or whatever, which are claimed by a lot of people, we most likely wouldn't be able to see it with a telescope. You would probably be able to see it with the LRO, because you're talking about a meter per pixel stuff there compared to us, which is, the closest we can get is zooming in on the biggest crater, which is, 200 miles across. Just think about that. I mean, that's, Philadelphia to New York, or Philadelphia, to Bill's house up there in the Hudson Valley. I mean, it's a huge area just for one crater. So, I mean, just like this, you're seeing, you'll see a complex crater pop up here on the screen.
Look at the shadow.
And you see that, and everybody's, oh, that's going to be a monolith. No, I mean, that's just going to be a regular complex crater, and, the sun's at a low angle. It's producing a nice big shadow,
Yep.
But, what, right now, I mean, Mark, he could calculate the size of that,
Well, actually, I'm going to write a program to actually do that, so people can just have it if they want it. There would be a way to actually do that, so people can figure out, by doing some measurements on their moon photos, they can figure out how deep the moon craters are,
right,
and how far they are now. Or they can go to the Lunar Reconnaissance Orbiter website, go to the quick map,
Right.
which I'm going to do a cloudy night stream on again, because it's I'm gonna name it right so I don't get kicked off of YouTube. Oh man!
I'll tell you, but listen, we've and we have to make this clear again, because a lot of people think, especially ones that are just coming in, we are not debunkers. Okay, we would rather put stuff through the scientific method. And if there's a logical explanation for something we are seeing, it's probably most likely that. You know, if we can explain it through normal terms and normal physics and stuff that we know about already, chances are it's going to be like that. I mean, there's not going to be a moon base hidden that big in plain sight for us anyway, especially if they're trying to hide it. If they're going to get it, it's probably on the backside, yes. Do we have any proof of that as of now? No. Am I saying there isn't a moon base up there? No. Am I saying there is? No. It's an unknown. We have no proof to back up the claims. That's all.
Yep.
Did I word that right?
I think so.
Yeah, very good. Well, I'll tell you what, those mountain ranges are becoming one of my favorite spots on the moon, especially lately, that they've been so clear and so, you know, just amazing looking. Especially this time when it's around 50%. Huh?
Which mountain ranges?
The ones you just scanned across a little bit ago. I don't know the actual real name for them.
Oh. Oops.
Yeah. Richard says, can we see some artifacts, please? What kind of artifacts would you like to see?
It's a big artifact, right?
Yeah.
Apollo?
I'm guessing you're talking maybe the Apollo stuff, and once again, you cannot see any of that with an Earth-based telescope. If you wanted to see any of those Apollo sites with an Earth-based telescope, if you wanted to make them just 2 pixels, you need a telescope 125 meters. I mean, it's just massive. And even then, it would only be 2 pixels. You wouldn't be able to tell any detail or anything like that.
When you consider one of the lowest res pictures we ever made is like a 320 by 240, 320 pixels by 240. And at that, the image is really rough. So a pixel is only one color. So with 2 pixels, seeing the Apollo landing sites within 2 pixels, you're going to have one pixel that's like a light gray and one that's a medium gray. You can't build a picture with just 2 pixels.
Well, one thing we can show you, like on screen right now, is the detail in the interior crater walls. And look at how they're stacked up. Really neat looking.
And Jenny is right. She said to Marc the Shark, Marc says he wants to see the footprints. Yeah, I agree. That'd be kind of cool.
Yeah.
But she's absolutely right. You do need a much larger telescope, as you were just saying.
The closest we can get to that is the rover tracks, which you can see with the LRO imaging. And you can see with the Chinese imager that's up floating around up there. And pretty soon, I'm guessing that India is going to be the next one with a presence on Luna.
Yeah, I'm thinking that may be true, actually.
This is the mountainous area, by the way, that I was talking about. He's the one he's going to now.
Beautiful.
Yeah, you can actually definitely see, I mean, just the amount of detail in it is just fascinating. We are getting, he's working on the focus a little bit. But, wow. Ted says footprints on the LRO. Are there footprints on the LRO?
You can actually, when you look at the LRO site, you can actually see the rover tracks.
I know the rover's there.
Yeah, and you can see the footprints.
Oh, okay.
Keep in mind that it's like looking at...
fake. It's from NASA. It's fake.
It's like looking at the footprints. It's like looking at the footprints, you know, in snow from an airplane, right? When you look at the footprints in the snow, the trail shows up because the footprints are deep in the snow, and it's the contrast of that shadow that you're actually seeing, not the footprints themselves. You're seeing the hole in the snow. Right. Similarly, it's the contrast of the footprint on the moon's surface, where the dirt, the dust, the regolith on the moon has been compacted under the shoes of the astronauts. And again, it's compacted dust that's never been compacted ever before.
Tim asked, isn't there a mirror placed somewhere on the moon, or was it just a plot for a TV show? Yes, there is a mirror placed there by Apollo astronauts.
Actually, there's a whole bank of them, and in several places. That's the retroreflector experiment. And my university, where I went and got my astronomy degree, is the university that actually made those retroreflectors for the Apollo program.
And once again, you have to understand those mirrors. They are not reflecting a laser beam back to Earth. They're only reflecting little protons that can be detected.
Well, they're actually what are called corner reflectors. They're like the reflector in your car, because no matter which way the light hits them, they reflect some component of the light back along the path that the light came in on. That's the whole purpose of them. That way, they can actually see something that comes back, because otherwise it wouldn't come back. You know, you'd say, oh well, I guess I never saw it.
Mm-hmm.
Yeah.
Look at this nice little interesting thing here. And I'm gonna actually circle it with the mouse here, but this little interesting formation down here. Pretty nifty looking, isn't it?
You're talking about? Yeah, that's true. That's true. Why don't we tell people what it is?
Go for it.
Well, let's find it.
I wish I knew what it was.
How could you not know what this is? Everybody knows what this is.
Well, I know what this is. I'm talking about this little U-shaped formation that looks like its own little Stonehenge area.
Yeah.
You know what I mean?
I know. It's not.
I'm pretty sure it has a name, but I don't remember what it is offhand. I guess it's part. Is it part of the bigger area there?
Well, is that Mare Serenitatis up where your mouse pointer is right now?
That is. Let me think. Let's see. Shifted around. I think so, because there is. Yeah, I believe so. I didn't see where we came from.
Well, it's okay. Look at the Terminator, which is we're on our side right here. So clearly, we're actually looking at.
That's the hardest thing with the big scope is, you know, because we are so zoomed in, it's hard to tell where you actually are in the north and south coordinates.
Yeah, I can see that. I'm trying to figure out where we might be based on the image here, and I'll figure it out. I should be able to figure it out here, because I know that we're actually we're close to something important here.
And I actually did. Some of you people might have saw in the last couple days. I did actually add something on here where we can go into negative view, if we need to, and I'll actually show you that real quick. So I can actually do that on this end now, actually with a slider instead of a button, which will allow me to set the parameters of the negative.
Oh yeah, look at that. Now it's made.
Yep. So if we're zooming in and we see something there, we can quickly dump right back into it. See that? Pretty cool, huh?
You can see that rill there on the right.
Yep. Pretty nifty.
Yeah.
All 90-degree strikes by rock. Statistically impossible for there. I'm not sure why you think that's 90-degree strikes for everything, but
well, he's talking about probably because the craters are circular. But what he doesn't understand is that the higher amount of energy of these meteorite strikes, you always get a circular crater, because and that's just physics, and we know that from physics. So you can say no, it's not, but then that's because you don't know the physics. I mean, that's okay. But 90-degree, they're not 90-degree strikes. They don't have to be 90-degree strikes. They just have to be energetic strikes to make a round crater. And that's what it is.
And look at this nice little arc right here of these. Biggest to smallest. It kind of reminds me of the Clavius craters.
Yeah.
Right here. Kind of moving past it.
Yeah, and you see that it has some inside. Yeah. It's really nice.
Really nifty. I mean, I don't know what it is, but I never get bored of looking at the moon. I have no idea why. Like a mental patient.
Well, see, Hitman is saying, "Well, I know physics." Well, I guess maybe if you did, then you would understand why craters are all circular. You said no oblique bowls. Well, that's not entirely true. There are some low energy impacts on the moon that are actually oblique, and their ray structure kind of shows you that they were oblique strikes, okay, like Meteor, the crater Meteor. So clearly, that's not the whole story. And the energy, of course, with which these strike are very very high, and they strike at many kilometers per second sometimes. So I get it, and I understand that. And it's and he says it's been proven they're not impacts.
Proven by who?
Research. So I have to do the research. See, it's always the guy who's telling you that it's me who has to do the research. The person making the claim never has to do the research. So that makes it easy for them, doesn't it? Makes it easy for them.
Who is this? Who has proven it? Do we have a name? Yeah. Do we have a paper? Do we have a peer-reviewed study that you could point us towards?
It's been proven.
Yeah.
They are not impacts. Okay. Well, okay.
Then okay. He just said electrostatic discharge, which is telling me he's in the electric universe theory, which is cool. I mean, it's a theory. Once again, I'm not totally read up on it.
Yes, it's proven electrostatic discharge. From where to where, and for what reason? What causes the buildup of charge? What causes the polarity? And which is a negative to positive, positive negative? What charged these objects up? I want to know that. So we can hear him tell us back that now.
Don't get off on rockets. Explain what you were saying about the craters.
Rockets don't even propel.
We're not. No. We're not even getting to there. Stick to the topic at hand. How are you coming up with it's been proven?
Yeah.
About your crater comment.
This is someone who
doesn't. This is classic people that just throw out statements and with nothing to back it up.
Don't expect to be proven.
Billy Yelverton, experiments in a lab. Billy Yelverton.
I've done them myself. He says, okay, well, then you should be able to refer us to your YouTube video that can show us
your paper, your peer-reviewed papers.
Yeah. All right. And
that is backed up by peers.
Yeah, and not peers of the docks, where they got sunk in the ocean.
Yeah.
So I don't know. I think that it is typical, though. People make these crazy statements without any backup, and then you're supposed to just believe it. Well, you know what? Maybe I don't have a whole lot of patience today, but I don't believe it.
Thunderbolts Project. That's exactly what. Yeah, he's electric universe theory. Which, once again, we're not saying that we don't know if it's true or not, but once again, the proof isn't there yet. It is a very good theory. I do know plenty of people that subscribe to that theory, but for me personally, it would take a little bit more study in order to. Electrostatic discharge can make those formations. Yeah, well, so can craters. Just because it can make doesn't mean it is what is.
It happened here.
Yeah.
It happened here.
I don't know. I mean, I would almost be more inept if he would have just came in and said, I think this is what it is, and here's why I think that, and here's why I'm convinced of this, and then lead us to his YouTube. But he's making it like it's a statement, like it's a proven fact that everybody knows except for us.
Yeah.
It's not the way to come at it, especially from a scientific standpoint.
Yeah, I don't like when people just throw things out with this authoritarian statements like this is how it is, and anyone who thinks otherwise is out of their minds and doesn't know anything. LOL. It's like, okay, you know what? You don't make any friends that way.
Yeah, he's still in the 90-degree thing after we've explained it already. So that tells you everything we need to know.
He's not listening.
Yeah, classic.
Away we go.
But hopefully he's right. Hopefully there is some kind of electric universe thing. It might open up doors, But once again, it has to be peer reviewed and it has to be proven. I mean, just on, a couple experiments, that might explain some things. But you have to have all parameters explained, which current physics does.
Yeah, I mean, we know there's holes in our physics model. We know that the standard model has issues. However, the impact science is actually pretty well understood. We can predict the size of a crater depending on what hits it, at what speed, and at what angle. And you can have meteors strike at any angle, and they do, and they have forever.
Right.
You can have low-speed impacts, high-speed impacts. The nature of the crater is slightly different. It's either going to be a round bowl crater or a round complex crater. In some cases where it goes where the meteor crosses and kind of grazes at the moon, you might actually get an elongated crater. But don't forget, gravity from the moon is actually pulling these things toward it as they're speeding through. So they are going to strike with some force, and they are going to dive into the moon with some really good force.
I guess we're Nash's shills now, Mark.
I guess so, because I guess there's no such thing as moon satellites, and LRO. And
Yeah.
Okay, fine. Hitman, you know what? You're kind of exposing your ignorance. I really think you should go home and go to bed.
Yeah.
Right. Because you're like I said, yes, the moon has no atmosphere. What's making the rocks at the surface? Why is everything 90 degrees with you? It's not.
Because round.
Because he doesn't understand what we're trying to say.
Because it has it hits it.
And impact energy, and that's okay. I'm trying to explain it, but they don't want to listen.
Because he's done it in the lab.
Yeah, his own lab apparently, which is probably his garage, with his little I don't know.
Do your research, man. We get that a lot from people that don't.
Yeah.
Do your research. So, believing in the physics that we have automatically makes us not do our research. That's very weird.
Let me ask you. I wonder if Hitman even understands what it takes to get the degree I got actually in astronomy. Maybe he doesn't, and it's okay.
It doesn't matter. It doesn't matter to them because they can do it. They can do it in a fish tank.
A lot of work to get that, and I didn't do this by just reading a book and then learning how to write an equation
or watching a YouTube video.
I spent years doing experimental research, proving theories. I actually did things to actually prove it. I didn't actually just read a book and say, "Oh, okay, I know a formula now." That's not how it works. And you know what? I gotta admit though, not everyone's gonna get that. I think the best way to learn is by actually doing it and seeing it for yourself. And the way I learned astronomy is, we heard about things like black body radiation, so we proved it. We proved what the radiation looks like coming off what was called an ideal black body. We tried to figure out how that ideal black body would look, and we actually generated our own what's called a black body curve. And things like that. They're characteristics of the universe. You learn so much more when you actually do things rather than just read things.
Hitman, we're not saying you are wrong. We're saying that what you're saying does not have the validated proof that it needs to be considered absolute. That's what we are trying to tell you. And now you're off on a tangent. We expect this from flat earthers, not from electric universe people. We're not dismissing the electric universe. We're not saying the universe is not based on electric. What we're saying is it is not confirmed. Please understand the difference. Stop acting like a flat earther or a nibtard and just understand what we are telling you. We're not dismissing you. We believe that electric universe theory is a very good theory.
Yeah, I mean, it's a theory that may catch on, but here's the thing. Okay, why are there little craters on the rims and no rubble? I'm just not listening. He doesn't want to hear the answer because
you could tell him the answer, and he would find some reason not to listen to it.
Request denied. That's his brain saying you can't come in with this information. I might learn something. That's okay. I wish him the best. Good luck.
Beliefs are fine. I mean, don't get me wrong.
I'm not going to be dealing with him anymore tonight.
Yeah.
Because I understand his issues. I don't want to. I'm just not going to deal well with them tonight.
Yeah. But we'll do our research and I guess wake up.
Yeah.
We're sleeping. We're sleeping sheeple.
That's right. That's right.
But yeah, I mean, once again, how many times have we talked about it on here that I would like to look into the electric universe theory and see what it's all about. I know Chris over at Take Back Space is really into that, and
I have no problem with it, the theory.
Robert Nickel, you don't have to spam the chat box, okay? We saw it. Jeez Louise. Yes, one hemisphere faces you all the time just because the rate of rotation of the moon equals the same. Mark, explain this, please. Why we only see one side of the moon?
The moon is tidally locked to the Earth, which means that there's one side of the moon that will always face us. Why? Well, the moon is close enough to the Earth so that the gravitational pull on the moon from the Earth will take the believe it or not, football-shaped moon is not quite spherical, and one side is actually denser and heavier than another, and the center of the moon is not the center of gravity of the moon. It's actually shifted. So there was a point where the moon's orbit, the rotation of the moon, was faster than it is now. That is to say, you'd see all the sides of the moon perhaps. However, we also found that over time that locked to our planetary rotation, so that as the moon spins once on its axis, it goes around the Earth once. Therefore, we only get to see one side from the Earth, which is really too bad. I'd really like to see the far side as well. You know.
Yeah.
So
how awesome would that be? If that rate of rotation was just like a little faster or a little slower.
Yeah, that'd be kind of cool.
You know, that'd be awesome.
We'd be able to say things like, "Is this the month we see Jackson?"
Yeah, I know, right? And once again, Jackson is one of my favorites because it's Tycho's twin on the other side.
Right.
Very similar.
Is Tsiolkovsky on the far side as well.
Yep.
Yep.
Love it.
Yeah.
Love it. And man, there's tons of craters. Tons of craters to explore on the far side. And who gets mad at saying dark side? Is it Commander Cobra?
What's he say?
He said, don't call it the dark side.
Yeah, right.
You want to call it the far side.
Yeah. I mean, that reminds me of that. In Pink Floyd, it's on one of the songs in one of the on Dark Side of the Moon album.
Yeah.
At the end, it's like, there's no dark side of the moon, really. As a matter of fact, it's all dark.
Yeah. The moon, for people that don't know, it gets the same amount of sunlight all the way around it. There's no
Ted,
real dark side.
Superman is real, Ted. Don't you even say things like that.
When we are in the new moon phase, the other side is in the full moon phase. When we are in the full moon phase, the other side is in the new moon phase. It's just our perspective because we are Earth. And there's actually a really good, it's actually a really good couple videos on it here on YouTube of why the moon looks the way it does certain times of the month. Explains it. But I think Hitman wants a soapbox.
Yeah, that's okay.
Yeah, poor fella. But hey, what can you do?
No, let me answer this one from him, though. This is actually a good question. Throw a rock at 45 degrees on the beach. What mark does it leave? It leaves an elongated dash on the beach. And now, do you know why? I can tell you why if you really want to hear it. The answer why is because it doesn't have nearly enough energy to vaporize itself and punch through the outer crust, that is, say, the sand on the beach, to the point where it can actually leave the circular crater that they always do. And I know that's hard to believe, but you have to just imagine and understand how the energy is distributed when an impact occurs. One thing that gives away the fact that it wasn't a circular impact, all right, is the ray structure distribution. There are craters like Aristarchus, which has a tremendous amount of debris on the western side. Well, guess what? That's on the Aristarchus Plateau. Or is that the eastern side, actually? So that's on the Aristarchus Plateau. And that eastern side of the moon, okay, you look at Aristarchus crater, and what shape is it? Round. Okay, that round crater, that was an oblique hit because the ray structure is easterly falling. So that shows you right there how craters that are made by oblique impacts are round, while their ejected debris can be to one side, because that gets thrown up in the air. And that is the thing that's subject to the physics of the incoming meteor. Okay, so that's right there, and that's something you just can't argue with because it's fact, and you can go see it for yourself. And I hope you do, because I'd like you to see that.
Amen.
Okay.
Right.
I'm not trying to be a smartass here. I'm just trying to say, it's actually, something to understand. I just think that, he has a solid opinion, and I think that's acceptable. People can have their opinions.
Yeah. Just so you kind of wonder how science failed so many people.
I ask that question all the time. And You know, I had someone just today. They called me a liar, and he wrote a post on his own page.
I know.
Mark,
I saw
you saw that?
Yeah,
You know,
I commented on it actually.
Mark D'Antonio is a liar, L-I-E-R. And I responded, well, yes, I am. I am a liar. I'm not a liar, L-I-A-R. I said I'm a liar, L-I-E-R. I do lie down, usually for about 6 to 7 hours a night.
I was gonna say that guy really didn't like you, did he?
Well, the thing is, he goes back and forth. I think he's got sort of a personality issue.
Oh.
You know, and so, I mean, there are days when he totally accepts who I am and knows my opinions are my opinions, and I tell him, hey, you know, everything is cool. That's fine. You can believe what you want. I'm okay with that.
Right. Yeah, as soon as Hitman started the name calling, he had to go. You know, we would have, entertained him if it wasn't for that. But once again, how it normally does with people that don't understand, they get very defensive and...
Are you talking about Hitman now?
Yeah, he had to go because I guess we're a bunch of F-sticks. I love how mad they get. They get so angry.
Yeah, because, you don't subscribe to their way of thinking.
Oh, I know.
Okay, I mean, I think this is the difference between...
Bigfoot, we were just zooming in for literally the last 20 minutes, and now we're on a wide field. Well, don't worry, we will go back to zooming again.
D, you're funny.
Yeah. Yep. So, yeah, but we'll be back to zooming. We're just looking at a wide field for a little bit. And we'll be back to the crater zooming. Yeah, we tried to give him the explanations, Ted, and he just, one of the things, I mean, he's the one trying to make these claims, and once again, we weren't saying his claims were wrong, but we were giving him answers of, especially when it comes to the electric universe, but we were just explaining to him, basically, the answers for his crater things, and he just didn't want to hear it because he is one-track mind, heading in whatever direction he chose. Yeah. And then if it came to that, you give them an answer, and they'll jump to another topic, and then another topic, and another. It wouldn't stay on point.
Yeah,
and
because
they get mad.
Lost that argument, and they want to move on to something they think win.
And they get name calling, and then it just...
They get tired of that, and then...
Angry little butterbeans.
When you finally exhaust their intellectual capacity, which doesn't take long usually with these guys, because they only read the first 3 or 4 sentences of a paper or a description to kind of get the science they need.
Yeah.
Then that's it. Now, I'm not saying that we're... no, actually, I am saying that we're more thorough and more science educated. I am, actually. And I'm okay with that because it's true. The guys like that, you're darn right. I don't sit back, and I make no bones about the fact that I've spent many years studying the science papers and trying to understand the universe. I do understand some of the aspects of the electric universe, and I will make it one of my Sky 2 radio shows one night. And when you get up on it, if you're up for it, then maybe you can join Amanda and I as well, Keith, and be kind of like a third wheel here to help us out if we want to talk about the electric universe.
Yeah.
You might have some stuff as well.
Yeah, I've been looking, as I said, I've been looking at it because, once again, our good friend over at Take Back Space, Chris, was into the electric universe theory, and I found it, interesting.
Mm-hmm.
And I was like, well, there might be some kind of merit to this, even though it might not explain everything. It does maybe give an answer to some things. And I was like, all right, that's kind of cool, and I wanted to read up on it, but I haven't had the time to do it yet.
Yeah.
But I don't know. Hopefully soon. But I don't see that happening anytime soon either.
Yeah.
Because I think we're about to be busy. But so look at the pretty moon, guys.
It's really pretty.
57.4% illuminated, cruising around, increasing, waxing until it's full, which I think the full moon is how many days into the cycle are we?
Can I read this theory to you here? I'll read this thing about the electric universe.
Yeah, go ahead.
Electric universe is an umbrella term that covers various pseudo-scientific cosmological ideas built around the claim that the formation and existence of various features of the universe can be better explained by electricity and magnetism than by gravity alone. As a rule, electric universe is usually touted as an ether-based theory with numerous references to tall tales from mythology. However, the exact details and claims are ambiguous, lack mathematical formalism, and vary from one delusional crank to the next.
Holy crap! Where's that definition from?
That's in the Irrational Wiki.
Oh man, that would be kind of biased, maybe.
Yeah, but still, I'm trying to, because they make these claims. They make the claim that general relativity.
What do they say?
Make the claim that Einstein's. Well, I'm telling you, the Einstein's postulates are wrong. General relativity is wrong. They think the universe is not expanding. They say that the electric force travels faster than the speed of light with near infinite velocity.
Well, here's the thing. What I'm saying is, like, in order for us to refute any claims that we know of, we have to actually learn about the actual theory itself, which, which is with anything. You know what I mean? In order to refute something, you have to learn about what you're refuting. So, yeah. I still think it'd be cool to learn about, And maybe even if it's not a truth, it might be something that may have partial truths to it, at some point in time and space. Might explain some stuff later down the line that maybe stuff we're trying to figure out when we do become a spacefaring race, traveling from planet to planet. So
yeah, except I don't think I'll ever say that my mind has been changed about comets. I don't think planets give birth to comets like the EU Electric Universe people think. And I don't think I'll ever say that stars don't shine because of thermonuclear fusion in their cores, caused by a gravitational collapse and heating and compression of the core to the 13 million degree threshold. I'll never say that that's not happening. I'll never say that instead they're anodes for galactic discharge currents. I'll never say that instead of the fact that they're collapsing matter.
Right. I know you're also basing that on what you already know. See, like, I can understand how some people, like people that don't know about that kind of stuff, I can see how they would get wrapped up, especially if it's presented in an all-knowing kind of way, which a lot of these channels are. Yeah. They're basically, promoted as fact instead of, this is a theory. Especially when it comes down to like Thunderbolt's project and whatnot. But I can see how people would almost start subscribing to it if they make it sound good enough without knowing the opposite of why we know that that's not the truth. You know what I mean?
Right. I mean, the Electric Universe folks say that impact craters on Venus and Mars and the Moon aren't caused by impacts from objects, but rather by electrical discharges, like we heard from what's-his-face. And the same applies to Valles Marineris, the Canyon on Mars, and the Grand Canyon on Earth. All right? Now, we're here on Earth, and we know how the Grand Canyon formed. We can see how it formed. It was formed by the ever-pervasive flow of water across the surface. It finally started cutting deeper and deeper and deeper. We watch it happen all the time. Yep. I climbed a cliff in Nevada prior to my talk on petroglyphs in Las Vegas. And when I climbed this cliff, I went up to the level of where the water was 5,000 years ago. Okay, and saw the petroglyphs that were along the shoreline of what used to be the river. However, the river is now down below by about 50 to 60 feet. And this is how deep that river cut into the rock over time. See, obviously the surface was there at one time, and obviously it was cut by water. So I don't think that it's some kind of weird electrical discharge. It's water flow. All you have to do is look at the results of a massive flood. Look at the results of the tsunami.
Let me say this real quick. For anybody watching the feed, and I could be totally imagining this, but I am seeing like little black dots moving across, and then I lose them. Like very, very, very small. So if anybody's on like full screen or... and I saw it was like a little bit, basically 5 o'clock at center is where I saw the last one. And then I seen one scoot across the top, eventually. Now, once again, I might be seeing that. It might be floaters messing with me like they always do. But if anybody's watching full screen or maybe are seeing something, if you do happen to see, I'm talking really, really small dots.
You might want to just wipe your screen, Keith.
No, it's not the screen, because they would stay stationary if that was the case. Well, these were actually moving.
All right.
And once again, they could be little floaters. But I could have swore I saw two. Just as you were talking there, I was like, what the heck is that? Very, very small. And of course, if they're black, they're probably a satellite, if anything. But,
yeah.
Kind of freaked me out for a second.
Yeah, I think so.
Palumbo, guy, dude. We will be going back to zooming shortly. Take a chill pill, buddy. Yes, we can zoom in, and yes, we can go, but we can go zoom very much. A long way. I'm not sure what to tell you. I don't know the exact distance from the moon it would be considered. But we can zoom in pretty good on individual craters. We can get close. Since you asked so many times. Just sit back, take a chill, and wait for it. You'll see. Oh, man, damn, I didn't even see Amanda here. Amanda's in chat, too. When did that happen?
Amanda's my co-host on SkyTour Radio, so let's all say hello to Amanda. Some of us know her, some of us do not. I mean, some folks do. I do. I know her.
Yeah, once again, if there is anything sighted, we use the clock on the screen in the upper left. Basically, this guy right here where I'm flashing it. You'll see it. Top left of the screen. And then, of course, if you can also name a zone that it was in.
You have a zonal overlay?
Just imagine a 4 or 6 equal boxes on your thing, and you'll see the zone thing pop up, and just imagine 6 equal boxes and just try to place it into a zone so people know where to look. And usually we find it on the wide field, the 70 millimeter wide field. The most is where you see most of the objects. But every once in a while, when we're zoomed in, we do have a friend that comes by.
Robel Palumbo, I just want to let you know that it's quite all right. I really enjoy your enthusiasm to see things zoomed in. Keith's just a little impatient, so just
the guy before kind of irked me, but I'm not going to take it out on Mr. Palumbo. I know. I'm glad he's enthused, and I welcome you, and I welcome your eyes to the stream to help us try to find some goodies. But yes, you will see us zoom in pretty good here in a couple minutes. And if you want to, I mean, if you don't want to wait, you can actually go back in the stream. You can go back up to 4 hours, so you can kind of jump back in the stream real quick if you want to, and check out ones that was about, what, 20 minutes ago, maybe?
Yeah.
Yeah. We were really, really tight in. But yeah, we will be going back there. Let's see. Should we do another update on who's in chat? Once again, welcome to everybody that's watching that is not participating in the chat. This is only going to tell me the participants who are actually participating in the chat. So we got The Witch and Alfredo and Chris and Dee and Amanda and Dorham and Jenny and Jess and Mark and Q and Mr. Palumbo. I think it's a Mr. Robert Nickel, Shep, Ted, Tom, and Vicky. That's who I have as participants in the chat. And once again, welcome to everybody who's not participating in the chat. It's just watching. We are live here with Marc D'Antonio of the SkyTour live stream in the SkyTour Radio on KGRA Radio, Sundays at 9 p.m. Eastern Standard Time, with his host,
you're good,
co-host Amanda Curran, who's also in the chat.
That's right.
KGRARadio.com.
That's right.
Yep. But man, it's
Commander Cobra's funny because when I talk to Commander Cobra,
he doesn't say A, does he?
No, he said here on KGR Radio.
Yeah, you know what? I didn't really get what you guys were talking about because I didn't really hear much of Commander Cobra, until up there at Bill's, and I was like, and I started listening to him, and he does the KGR Radio. He totally forgets the A. I don't know. Maybe that's one of those kind of little brain tics or something that people have. That just can't.
No. I think you're going to hear that he's going to say it more often.
Oh, he's been doing it. He's been on KGRA Radio.
He's doing that because of me.
Yeah.
Because he and I we're doing a live show together one time, and I heard him say it, and I went, "It's KGRA Radio."
I mean, it's like KGR
KGR Radio here on KGRadio.com.
Yeah.
KGRARadio.com.
Well, we did it. Some people get pissy when we have the music on. Some people get pissy when we have the music off. You just happen to be on the other side tonight, so you can miss it for a night. We'll be taking a break shortly, and then I'll throw on some music for you, at least for a little bit.
Yeah, actually, Robel Palumbo, I wanted to mention, you you actually have an outlet to look at the moon in much higher resolution than even Paul and Keith can show you. If you go to the Lunar Reconnaissance Orbiter website, or just look up LRO Quick Map, all one word, Quick Map, and you will find a online mapping segment of the moon where you can actually pick tools to check out the moon. You can zoom in and zoom in and zoom in endlessly until you get down to a ½ meter per pixel. And when you look at that distance, we're looking at something that's only about 30 feet across or so.
Yeah.
So you can actually see really, really, really well.
And you can see all the Apollo sites and the tracks and the rovers left over and all that good stuff.
And in some cases, because the rover, the LRO was actually dropped down to just a few miles off the moon, okay, for an elliptical orbital pass, you can actually see the lunar sites in unprecedented quality, and you can see things like the flag on the moon.
Especially when the sun angles at a certain point, you can actually see a very large shadow from it.
Yeah, you can see a shadow, and you can see down on top of it as well. And that's pretty exciting to be able to see that. And you can see the descent stage sitting on the moon. You can see the rover left behind. You can see all the tracks, the walking tracks and rover tracks. And it's pretty cool. And it'll give you an appreciation of just how big the moon is. What you see on the screen there is something that's just over 2,000 miles across. 2,000 miles. So just imagine how far you have to zoom in to see like a car on a highway when this is overall 2,000 miles across. Go to Google Earth and pick a 2,000 mile across segment of the United States. All right? And then zoom in as far as you have to see a car on a highway and see how that zoom level actually works against you when you're trying to see stuff on the moon.
Yeah, and actually Jess had a really good question there, Mark. She said, if this telescope was on the moon, how well would we see Earth? Will we see airplanes fly by like specks? We sometimes see go by here.
Well, it depends what kind of telescope we're talking about. If
she's talking about this one we're using now.
This one here?
Yep.
Oh no, we still would not see that.
Right.
We might be able to see contrails, however, if we were looking back at the Earth, because the Earth is of course bigger than the moon, and depending on what the contrails do, they might actually spread out over the course of a day. You could actually probably see the contrails from the moon, but you wouldn't see the airplanes, not with Paul's telescope.
No.
That's a 70 millimeter triplet, right? So he's using.
Yeah, right now. Yeah, but if it, say we use the 9.25.
Yeah, I don't think you'd see the.
I don't think we would either.
Airplanes. Yeah, that's like saying you'd be able to see a satellite orbiting the moon from here, and you simply can't do it.
Yeah, and once again, it all comes down to something called the diffraction limit. Dawes limit.
Right. Yeah, that's right. Well, same thing. I mean, yeah, we'd get to the point where the optics cannot resolve something any better than it has, and that's exactly what that is. And it depends on the actual size of the mirror.
Yeah.
And that's something that's important.
And a lot of people have a hard time understanding that if we point Hubble to the moon, it wouldn't be that great. I mean, granted, you wouldn't have all the atmospheric distortion that we have, but you still wouldn't be able to resolve the Apollo sites or anything like that with Hubble. No,
in fact, that's the thing with Hubble. Okay, based on the size of its sensor, the truth is, the Hubble telescope really, at best, has a 0.05 arc-second per pixel resolution. Now, what does that mean? Well, okay, 0.05 arc-second per resolution per pixel is something that is actually outside the. It's not. Let me say it this way: the objects on the moon can't approach the resolution that we need to see them. They don't. The Hubble Space Telescope can't see them because of that limit, and it has to do with the fact that the Hubble is only 8 feet across. The James Webb will be 21 feet across, so we might actually have a better chance with that. Well, I'll tell you what, it is. We still won't see objects on the moon with even the James Webb.
I can't believe it's 11:15 already.
I know.
I'm gonna text Paul to see if we can do one more loop with the big guy. And then, because I know he said we were trying to wrap up at 10:45, so because we do have day jobs, but
I'm wrapping up at 10:45 myself.
One more loop with the Zoom. Let's see what he says. Cause I'm wondering if he'd put it away already, because we did have that kind of scheduled. Scheduled to be pretty much wrapping up at 10:45, but man, oh man, time freaking flew. But once again, this weekend, if it is nice, Friday night and Saturday night, we will be live with the long streams, and you guys know what I mean by the long stream. Sometimes they go 5, 6, 7 hours.
No
so,
way.
Yeah, especially if you come on.
Oh boy. This weekend?
Yeah. Well, I don't know. Yeah, Paul's gonna go one more round with the big scope, and then we're gonna wrap it.
Okay, I've got my radio show on Sunday night to do, and I think I have another. What am I looking at here? Yeah, I have a 24th. I have to be in Massachusetts doing another talk.
Sunday.
Yeah, so I have to do that, and then I have to. Actually, you know what? I might have to do a pre-record on this Jupiter thing, because I think I'm going to be in Massachusetts for 5 p.m. Unless I do my show live from Massachusetts, which I might be able to do.
You might be able to.
Yeah, I might be able to. All right, we'll see. I'll figure this out.
Paul says he's having trouble correcting the time on the scope, which is weird. Never had that problem before. He's getting bad alignments because of it. That's weird.
I gotta come the 22nd. I'm supposed to be on ERRT. What's that? 5 p.m.
I have no idea. Is Ron actually getting a listenership over there, or?
I don't know. I mean, that was the other day.
Yeah.
Yeah.
Cool.
Amanda had a Paul McCartney special that she was playing for Ron and managing. Let's find.
Nice.
Let's find out.
All right, guys. What we're going to do right now is we're going to go and we're going to do one more loop with the big scope, just one more scan, and then we're going to wrap it up for the night. And Marc's trying to find that data on the on ERRT radio currently.
Actually, yeah. That's Amanda saying, no, you got to listen to my show. She's got something on ERRT radio. Oh, okay, Amanda. Now I get it. Okay, I will go listen, of course. I'm added to my calendar.
Don't stretch yourself thin, Amanda.
That's it. She'll do what she needs to do.
Yeah.
I know that. And Amanda, the other thing is, on Sunday at 5:30 in the evening, I have to be in Massachusetts doing a MUFON talk. So I think that I'm either going to do that show on Jupiter live from Massachusetts, or I will be doing it as a pre-record. I'm not sure what we'll do, but I'll let you know. I'm not going to leave you hanging, of course, because you are the co-host. So I'll talk to Bill and figure out what's best, because I do want to get this done, and hopefully we'll. I'm sure we could talk about plenty of things up there, and do a live show. But
Jess, if you're talking about Marc's show that he's talking about now, it's on KGRARadio.com Sunday nights at 9 p.m. Eastern Standard Time. If that's if you're talking about this show, it's Scope's in Miami and I'm here in Pennsylvania. I'm not sure which one you're talking about, but there's info for both.
Right. And I was told, Amanda, that Eric has Skype up there and everything is usable, but I have to contact Eric to find out, because I'm not going to go up there blind. My computer, my laptop won't give me that, but I could use my phone with no problem, and my phone will work, but I won't be able to use this microphone setup. So it would be, either way, it's going to be less effective, but I will, I see you remember now. I will be up there with Eric, and we'll see what happens.
We will see what happens. So I'll tell you what I'm going to do right now. I am going to wrap up with us. I'll put the music on for the rest of the time as we go for our last little our last little zoom around the moon. But I'll wrap it up. So Marc, thanks for joining me once again for a hangout, and we might do it again pretty soon. And we'll see you guys next time.
Right. Hey, everybody. Thank you for having me here. I see Jenny's eating again. That's good. It's always good to have nutrition. And I will talk to all of you at another point soon. Tomorrow I have a science council meeting at night. I'm on an advisory council for science, and I have to do that tomorrow night. So if you stream tomorrow, I can't help you.
No, I won't call on you again for a late night. You know, especially since you got a lot going on this weekend.
Well, today was a day we started filming at 8 o'clock.
Yeah. Yeah. And we'll probably be doing that the rest of the week too. You know.
Yeah, finished up a couple hours ago. So actually, just before I came out with you. So actually, my voice sounds pretty good for talking all day.
Not bad.
No, that's
not
true.
bad. Get yourself some cough drops and some water.
Water anyway, yeah.
Right.
I'll tell you one thing, ice water never sounded so good, let me tell you.
Right. All right, guys. Well, we're going to wrap it up. Be sure to check out SkyTour livestream, Marc D'Antonio on KGRAradio.com, Sunday nights at 9 p.m., along with Marin the Curran. And you can check out the SkyTour live stream on YouTube here if you want to go learn a thing or two about some deep sky objects and some stars and all kinds of other stuff. And I'm usually hanging out over there as well. So we will see you next time, and enjoy the rest of the Zoomies, and then we'll wrap up after he's done this last scan. So thanks, everybody. We'll see you next time.
Guys, good night all.